Okay, whenever you have an equation with an x in an exponent, the way you want to solve it is by taking the log or the natural log of both sides. In this case, I'm going to take the natural log. Now the reason you do that is there's a rule that says if you have a natural log, if there's an exponent inside the natural log, you can bring it out of the natural log. So that means that the natural log of 2 divided by the natural log of 1.06 is equal to x. Now if you wanted to find out what that equaled approximately, uh, 11.9. Okay. So the next one is very similar. We just take the natural log of both sides, and you can use log if you want. You don't have to use the natural log. So the natural log of 5 is equal to x times the natural log of 1.3. So that means the natural log of 5 is equal to the natural log of 1.3. Now these equations actually lead into how to do the base change formula, which I have another video for. So 6.13 is approximately equal to x. Okay, now this one isn't actually as bad as it looks. A lot of students freak out once they see a base other than 10 or e, but it uses the same rules that log base 10 and log base e use. If you have two logs being added together and they have the same base, then you can actually multiply the stuff inside of them. Okay. And combine it into one log. Now when you have two logs set equal to each other with the same base, then that means the stuff inside of each other has to be equal, otherwise these two things would not be equal to each other. So that means x times x minus 3 has to equal 5x minus 1. So the hard part of this one is that we're going to have to actually use the quadratic equation because it's non-factorable. Okay, so we have this quadratic. Let's subtract 5x and add 1. So minus 8x plus 1 equals 0. So the quadratic equation is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 1 all over 2 times 1. I'll complete it over here. So x is equal to 8 plus or minus the square root of 60 over 2. X is equal to 8 plus or minus. Now I should try to simplify this square root. So that's the same thing as 4 times 15. The reason I did that is because I know what the square root of 4 is. It's just 2, so 8 plus or minus 2 times the square root of 15 over 2. And now I can divide each of these individual terms in the numerator by 2, so it's going to just be 4 plus or minus the square root of 15. Okay, so the first thing I want to do is try to rewrite this into a log with nothing being multiplied by it. Whenever you have a number being multiplied in the front, you can just raise it to the exponent, so x squared. And I want to combine this into one log. So log of x minus 1 times x plus 10. Okay. Well, now I have log base 10 is equal to some other log base 10, so that just means that the things inside the logs have to equal each other. Sorry, my pen is giving me some trouble. So that's x squared minus x plus 10x minus 10. So it's x squared is equal to x squared plus 9x minus 10. Okay, well if I subtract x squared from both sides, I'm just going to have 0 is equal to 9x minus 10. So if I add 10, then I'll have 10 is equal to 9x, and then if I divide both sides by 9, I'm just going to have 10 over 9 is equal to x. Okay, I want to combine this left-hand side, where's my thing? Okay, I want to combine this left-hand side into one natural log, so okay. Now, whenever you want to get rid of a natural log, just as when we wanted to get rid of an exponent, we used natural log. If you want to get rid of a natural log, you use e, so we'll do e to the natural log. X minus 1 equals e to the 4th. Okay, so that just means that x over x minus 1 is equal to e to the 4th. Okay, so that means x is equal to x minus 1 times e to the 4th. Distribute the e to the 4th, so x is equal to x times e to the 4th. Whoops, that doesn't look like a 4. E to the 4th minus e to the 4th. Okay, I want to get the x over here, so x minus x e to the 4th equals negative e to the 4th. Now I'm going to factor out my x, so 1 minus e to the 4th. One minus e to the 4th is equal to negative e to the 4th. Let's finish it up over here. So if I divide both sides by this 1 minus e to the 4th thing, then I'm going to get x is equal to negative e to the 4th divided by 1 minus e to the 4th. Now if you want to approximate this, some students probably would have given up a while ago with using the e to the 4th notation. They would have just went ahead and found out what that was, because having the e can be confusing for some people, but I left it. So second e to the 4th divided by 1 minus e to the 4th. So approximately 1.12. 0.12. Okay, if you want to solve for an x and x exponent, take the natural log of both sides. Now there's two ways you can deal with this one. You could leave it like this. However, if you take the natural log of 1, you're just going to get 0, so you might want to do this. Okay, whenever you have a fraction on your natural log, you can split it into two natural logs being subtracted from each other. Since that's 0, this is just negative natural log of 2. Okay. Now this over here would be 3x minus 1 times the natural log of 4.33. Okay, so now I want to just divide both sides by the natural log of 4.33, so 3x minus 1 divided by the natural log of 4.33. Okay, Now I add 1 to both sides. Oops, sorry. Finish it up over here. Okay, so that is the exact solution. However, if you would like to find out what it is approximately, negative natural log of 2 divided by the natural log of 4.33 plus 1 divided by 3, 0.176. 0.176. Sorry, that should be approximately. Okay, so usually I just use the natural log all the time. However, if you ever see a 10, it's helpful to use log, because if I take the log of this side, I'm just going to get 1, because the log, the common log base 10 of 10 is just 1. So let's do the log this time. And, you know, your calculator is going to have a log function in it, so you might as well. Generally, you stick to logs and natural logs because that's what your calculator has. Okay, so this is just 1, which is why we did the log. I can bring this out to the front, so 5t minus 2 times the log of 1.05. Now you totally could have used natural log, it really doesn't matter, it's just a little easier. And I'm going to write the natural log of 10 over here, so I'm going to divide both sides by log of 1.05. Okay, so I have 5t minus 2 equals 1 over the log of 1.05. Then I'm going to add 2 to both sides. And then divide both sides by 5. Okay. 1 divided by the log of 1.05 plus 2, all divided by 5. So t is approximately equal to 9.84. Okay, this is the last one I'm going to do in this video here. So, whenever you have something with an exponent, and you have an x in the exponent, just take the natural log of both sides, or you can use log, it doesn't matter. Sometimes it's easier to use natural log, and sometimes it's easier to use log. The only time it's ever really easier to use log is if you have a base of 10 in one of these exponents. Okay, so the reason you do this is that you could bring the 7x minus 2 down to the front times the natural log of 4 equals the natural, x times the natural log of 3. Okay. Now, there's a few ways to kind of deal with this. You got an x here and an x here. There's a few ways to deal with it. The way I'm going to deal with it is by distributing. You might not like this way, but I think it's the most straightforward. Well, I mean, it's about as straightforward as you can get with this. Okay. So, I want everything with an x to be over here on the left and everything without an x to be on the right. So I'm going to add this to both sides. So I'll have a 7x times the natural log of 4 equals x times the natural log of 3 plus 2 times the natural log of 4. Excuse me. A lot of students get really thrown off by these natural logs being in here. Remember, they're just numbers, okay? So this is just 2 times some number, okay? So we can add and subtract it from both sides. This is x times some number. So I'm going to subtract that from both sides so that I'll have all of my terms containing x over here. Okay. Now if that had just been a 5, or if that had just been a 7x with no natural log there, and a negative 1x, you would just add the coefficients or subtract the coefficients. Well, our coefficients are 7 natural log of 4 minus natural log of 3. So let's subtract our coefficients. Think of this as I'm just factoring out the x. Okay, so you could think of it as you're adding the coefficients, or you could think of it as you're factoring out the x. I like to think of it as factoring, actually. So now I'm just going to divide both sides by that stuff. So x is equal to 2 times the natural log of 4 over 7 times the natural log of 4 minus the natural log of 3. Okay? So 2 times the natural log of 4 divided by 7 times the natural log of 4 minus the natural log of 3. Make sure you put the entire denominator in parentheses, otherwise your calculator won't do it correctly. So x is approximately equal to 3.22. Or 0.322, excuse me.